Okay, today we're going to do practice E. Now the first problem, it says to look at sample problem E from the textbook, so I typed sample problem E above it. So what you need to do is you need to get the information in the given from the sample problem and then use that to answer number 1. I will work number I'll work number 2. So it says a car traveling initially at 7 meters per second. So we're going to write our given. The initial velocity is 7 meters per second. It accelerates uniformly at a rate of 8 meters per second squared, 0.8 meters per second squared, for a distance of 245 meters. A, what is the velocity at the end of the acceleration? So we want to find VF. Then it says, what is the velocity after it accelerates at 125 meters? So now we want to find VF at 125 meters. And then C says, what is the velocity after it accelerates for 67 meters? So now we want to find VF at 67 meters. So basically we're going to do the same thing 3 times, and we're just going to use different values for x. So first of all, to know what equation we're going to use, we do what we always do. We have VI, we have A, we have x, and we want to find VF. So these are our 4 variables. So now I'm going to look at my equations and see, I'm going to use the equation VF squared is equal to VI squared plus 2AX. Since I want to solve for VF, I'm going to rearrange the equation to solve for the unknown in terms of the known. So even though VF is already by itself on one side of the equal sign, there's a square. So I'm just going to take the square root of both sides and say VF is equal to the square root of all this, VI squared plus 2AX. And now when I solve for VF, for part A, VF is equal to the square root of 7 meters per second plus 2 times 0.8 meters per second squared times 245 meters. So now when I put that on my calculator, VF comes out to be 21 meters per second. Now remember, what I want to do is I want to carry my units through and cancel them. So let's look at my units. Underneath the radical, I have meter per second there. And then over here, I have meter per second squared. Whoops, I left out. This is squared. So this whole thing is squared. And then meter per second squared times a meter. And you know, by looking at the units, I looked back and I actually caught my mistake that I forgot the square. So that's why it's important to do this, because I was like, wait a second, these units aren't going to work out. So now when I multiply this out, I get meter squared per second squared plus meter squared per second squared. So I'll have meter squared over second squared. Now when I take the square root of the number, I also take the square root of the unit. So the square root of meter squared over second squared would be a meter per second, which is the correct unit for velocity. So now I did it right. So actually I made the mistake because I forgot my squared from here to here, and by looking at the units, I caught my mistake. And that's why you always carry your units through and cancel them in order to check your work. So part B is just the same thing. You know, VF is equal to, and I'm not even going to write the equation here, I'm just going to write, 7 meters per second squared plus 2 times 0.80 meters per second squared times 125 meters. So this comes out to be 16 meters per second, and then you do the same thing for part C. So all these problems all use the same equation. And for number 3, you have to use another equation to find the time. For number 5, that's like that other one I showed you, because number 5 It says an aircraft has a liftoff speed of 33. So again, for number 5, this is E5, what you want to do is you want to kind of draw your picture. Here's my airplane. So my airplane's on one end of the runway where it's not moving, VI is 0. For liftoff, the final velocity is 33. That's when it's going to take off. And then we want to find, though they give us X, they give us this X is 240, and then you want to find A. So you use this same equation, VF squared is equal to VI squared plus 2AX, but you have to do your algebra. You're going to rearrange this equation to solve for the unknown in terms of the known. So first I'll subtract that from both sides. VF squared minus VI squared is equal to 2AX. And remember, I'm solving for the A, so I want that to be all by itself in the numerator on one side of the equal sign. So now I'll divide both sides by 2 and X, so VF squared minus VI squared over 2X is equal to A. And then I can substitute my values and then solve. And that's it. So these are pretty simple. These are just like the other ones that we did. The only difference is that they're using a different equation. And that's it.